Hi, this is Mrs. Kidman, and in this video, we are going to be discussing reference angles. So what are reference angles? Well, reference angles are relating the terminal side of an angle to the x-axis here. So what it does is it's basically saying if we were to put this angle on a coordinate plane, where is it in compared to that x-axis? So we end up seeing this pattern, especially in the unit circle when it comes to these reference angles, where we see that the reference angles all happen to be the same distance away from that x-axis. So in this example here that you can see on this screen, we have this distance away from the x-axis here. Now, we call it a reference angle because this distance, if we went straight across here, would be the same distance as what we would find in this case. And it would also be the same if our function were to bounce and be over here. Okay, so all of these angles here are all compared to how far away they are from the x-axis, what that degree is. And depending on that degree, we actually start to notice patterns about angles with its location, especially with respect to radians, in which you can learn more about in a different video. So we are going to be exploring reference angles and how we can find them. So let's take a look here and talk about what kind of notation we're going to use. So when it comes to our standard angle or our original angle, we're going to be using the notation theta. And our reference angle is going to be theta prime, or theta to the power of 1. But what we're going to do is we are going to find these reference angles first by sketching a picture of our angle. So we're going to draw our x and y axis here, our little t. In this case where we have a positive angle, we're going to have 0, 90, 180, and 270. And then we are going to want to just sketch a picture of our angle here. So we're going to start at 0. 60 is 2/3 of the way between 0 and 90, and we are going this way with our angle. Perfect. So then what we want to figure out is our standard angle here is actually going to be 60. Now, to figure out our reference angle, we want to know how far away it is from the x-axis. So we're going to look. Here's our x-axis. I'm going to highlight it in blue here. So there's our x-axis. Is it closer on the right side or on the left side of our x-axis? Well, in this case, it's closer on the right side. So we want to figure out how far is it from here to here. How far is that blue arrow? Well, when it happens to be in quadrant 1, our standard angle is equal to our reference angle when we're in quadrant 1. And the reason why is because in quadrant 1, it is just going to be closest to that line of 0. Now, this is not going to be the case. The reference angle and the standard angle are the same in the other quadrants. So what we're going to do is we're actually going to go through and explore some different angles, find their reference angles, and in the end, we're going to come up with a method that we can use so that we can find the reference angle in any quadrant of our angles here. So let's take a look at another example. This case, we have a standard angle of 135 and we want to find our reference angle. So we're going to do that first by sketching our angle here. So we've got a positive angle. So we've got 0, 90, 180, and 270. Okay, so as we have these here, we're going to start at our 0. 135 is between 180 and 90. So we're going to come over here and we are going this way. Now, to find our reference angle or our theta prime, what we want to do is figure out which x-axis is it closest to. And we can see that it's definitely closer here than it is being closer to this axis over here. So we want to figure out what is the angle measurement of this angle that's been shaded blue here. And so what we can do is if this is 180 and we know that this is 135 degrees, we can just figure out what the difference is between those two. So we can just take 180 minus 135 to figure out how far away that 135 piece is from being 180. And 180 minus 135 is going to give us 45 degrees. So in this case, our reference angle is going to be 45 degrees. So what do we notice here? Well, when it is in quadrant 1, we take our standard angle and it's the same as our reference angle. When we are in quadrant 2, based on what we see here, we can take 180 minus our standard angle here in order to get our reference angle. Now let's take a look at some other examples here. Now in this case, we have 240. So let's go ahead and sketch our angle here. Again, we're still positive, so we've got 0, 90, 180, and 270. we're gonna sketch that angle here. So 240 is between 180 and 270. It's about right in the middle there. We are going this way. Now, again, remember our reference angle is trying to figure out which one is closest to the x-axis. So as we look at how close we are to the x-axis here, we notice that it's actually closer to this side than it is to that side. So we want to figure out what this distance is. So in this case, what we're going to do is if this is 240, to figure out how far, what the degree is to go from 240 to 180, I'm just going to take 240 and subtract 180 from it. And so 240 minus 180 is going to be 60 degrees. And so in this case, our reference angle is going to be 60 degrees for this problem. Now, making that a more generalized statement, notice how we're in quadrant 3 here. And anytime we're in quadrant 3, say my line was here, say it was here, say it was here, it's always going to be in quadrant 3. Everything's going to be closer to this x-axis here. So we always can use the idea of if we're in quadrant 3, we want to take our angle and we want to subtract 180. Now let's not get this confused with what happened in quadrant 2 where we took 180 and subtracted our angle. Now, what we might want to explore here is what happens when our standard angle is in quadrant 4. So let's go ahead and sketch this picture, make sure it's actually in quadrant 4 here. So as we go to sketch it, we have 0, 90, 180, and 270. We can sketch our 330 here by knowing that 330 comes over here, because remember, if we do a full loop, that puts this back at 360. So we are looking about right here. Our angle is going all the way around. Now, which side of our x-axis is it closer to? If this is our x-axis, it's definitely closer right here. And so how can we figure out how much closer it is? Well, if this is 330, to go to 360, we have to add 30. But if it was over here, that wouldn't always be the best case. So what we can do is really we're taking 360 and we're subtracting 330 degrees to get to that quadrant. And notice again how we're in quadrant 4 here. So in order to find our reference angle in quadrant 4, what we're going to do is we're going to take 360 and subtract our standard angle. Okay, so with that in mind, let's kind of detail out what we do with our reference angles. So these are our reference angles. And we want to figure out how we can calculate those reference angles. What we are going to do is it depends on the quadrant. So if we're in quadrant 1, our standard angle, or whatever they give us, is equal to our reference angle. If we are in quadrant number 2, what we found out is we can take 180, because this axis here is this side of the axis here is going to be what we're closest to, and we can subtract out our standard angle to get our reference angle. Now, if we're in quadrant 3, what we can do is anywhere in quadrant 3 is also still closest to this side here. So, but because our angle is actually bigger than the 180, we're going to do our angle, whatever we're given, minus 180 to get our reference angle. And lastly, if we're in quadrant 4, then our angle is going to be closest to our 360 side, or our 0 side. And because it's going to be that distance, we are going to take 360 minus the angle that we're given, that standard angle, in order to find our reference angle. So if we wanted to find those reference angles of some other ones here, what we can do is we don't have to sketch a picture every time and then look at which one is closest. If we sketch our picture and decide where it goes, then we can use whichever pattern. Decide where the terminating end is located, which quadrant, then we can use the pattern that associates with that quadrant. So let's take a look at a couple of examples here on how we would do that. So say we had 40 degrees. We have 135 degrees. We have 210 degrees, and we will look at 305 degrees. Okay, so let's take a look at each of these. If we were to look at all of those and get them on our little, sketch a little picture of it here, 40 would be between 0 and 90, so it would be right here. Because it happens to be located in quadrant 1, then we know that the reference angle, let's see, Let's erase this here. We know that our reference angle is then going to be the same as our original angle, or 40 degrees. Now, if we're at 135, if we go to sketch that picture, we've got 0, 90, 180, 270. In this case, we will draw our angle. It's going to end up right here, where it's over here in quadrant number 2. What we are going to do to get our reference angle is, if we're in quadrant 2, because it's less than 180, but closer to 180 than 0, we're going to do 180 minus our original angle there to get our reference angle, and 180 minus 135 is going to be 45 degrees there. Okay, and then we can look at our 210 here, see if it follows that same pattern, and this makes sense, right? If we're looking at this, this seems like it could be 45. This obviously is the same because that's our angle. Now, taking a look at our 210, we've got our 0, 90, 180, and 210, 270, and then we can sketch our picture here. So our 210 is going to end up over here. We're going this way. It's still going to be closest to this side of the axis right here. So we can just take, for our reference, we can take the angle that we were given, so the 210 minus 180, and we can see that our reference angle is 30 degrees, which is about what that looks like. So we can see how that pattern works there. Now, when it comes to our negatives, or our terminal, or our coterminal angles, if they happen to be coterminal, what we want to do is we want to do what we've done before, and we want to sketch the picture of it. So let's sketch it, and then depending on the quadrant of our terminating end, then we will use whatever patterns associated with it. Okay, so let's take a look at this one. We want to sketch it. Well, to sketch this at 400, I'm going to first start by subtracting 360 degrees from it, and 400 minus 360 is 40 degrees. So that's its coterminal position there. So that means if we have our 0, 90, 180, and 270, what we can do is we can just graph it the way that we or sketch it the way that we had it before, right here at our 40 degrees. And as this is at 40 degrees, because we happen to be in quadrant 1, we know that if we're in quadrant 1, the standard is the same as our reference angle. Therefore, our reference angle is also going to be 40 degrees in that case. Okay, and we can do that any single time. Just use that reference angle, use our coterminal concept there to find the coterminal angle and figure out what other angle is there, and then use our pattern. So if 400 degrees is in the same place as 40 degrees, and it happens to be in quadrant 1, then our reference angle is 40 degrees. If our coterminal angle ended up being 140, so say we ended up having 500 here and we got 140, as we go to sketch our 140 over here, where this would be 140, then what we can do is follow that same pattern. So our reference in this case of our purple angle is going to be 180 minus our 140 degrees, and it's still going to end up being that 40 degrees. So we want to use that coterminal angle, the one between 0 and 360, to find this. Now, we can use that same idea when it comes to negative angles, or we can kind of go the other way. So let's take a look at this negative one. If we wanted to use the coterminal concept, we could just add 360 to this and graph the positive side. We also can graph it. We also can sketch an image of it in the negative direction, just like we have been. So 0, negative 90, negative 180, negative 270. And as we go to sketch this here, we know that negative 315 is going to end up over here. And we are going this way. Now notice, we here are in quadrant 1. And so when we're in quadrant 1 here, if we're using these negative angles, then what we need to do is we actually need to take into account how far away it is from 360. So the rules kind of go backwards. So if we want to use the negatives, then our rules are going to change. So here in quadrant 1, what's going to happen is we're going to do the 360 plus our negative angle, because it's that negative angle there, right? And then in quadrant 2, we would take our angle and we would subtract, or we would add 180, things like that. But rather than dealing with the negatives, because that can be a mess in figuring all of that out, let's just switch it to a positive. So what I would like you to do is just add your 360 to it. If we add 360 to this, we end up getting 45, and we can just sketch our angles as our coterminal in the positives. And as we sketch this, we can see that we end up at 45 degrees. And because we are in quadrant 1, then it's actually going to be that 45 degrees. So rather than trying to figure out which pattern to use with the negatives and reverse them, I would highly recommend finding the positive coterminal angle and using our positive rules there. So again, just to kind of cap that off, if we are here and theta is our standard angle, and theta prime is our reference angle, then if we find, now this only works with the positive coterminals. So positive coterminals between 0 and 360 degrees. Okay, so that's kind of what we're looking at here. So if I have a standard angle and it's positive coterminal between 0 and 360, it doesn't matter what it is. To find its reference angle, find the coterminal between 0 and 360 and sketch the picture of the angle. Depending on where that angle is, if it's in quadrant 1, our standard angle and our reference angle are the same. If it's in quadrant 2, we take 180 and subtract our standard angle to get our reference angle. If we're in quadrant 3, we take our standard angle, subtract 180, and we get our reference angle. And if we're in quadrant 4, we take 360 and subtract our standard angle to get our reference angle. Again, when we talk about our standard angle here, it's standard in quotes because our standard angle in this sense has to be a positive coterminal between 0 and 360 for this to work. But if we're willing to do that, this pattern will always work for us. So if you have any questions, don't hesitate to reach out, but this is how you can find reference angles given any type of angle if we have it in this plane here.